Okay, now we're finally going to get to determining delta H experimentally. Remember, delta H is enthalpy, and the general category for delta H is either exothermic or endothermic. So we're going after delta H finally, and that's by way of experiment. And so the overall equation here for delta H delta H by way of experiment is taking Q divided by the amount. And remember, the Q is the same as MC delta T. Now, the general units for your delta H are an energy, which is your Q, per an amount, which could be grams or moles. And our energy could be joule, kilojoule, calories, kilocalories. And remember again, exothermic delta H is negative and endothermic delta H is positive. And the reason why that you must realize that again is because this, with your determining delta H experimentally, you have to physically put the positive and negative sign in at the end of your answer, or at the very end. Now, the thing to remember is watch your water, because the Q will always come from the water, the MC delta T, the mass of your water, specific heat of water, and change the temperature of your water. So if your water increases it received heat from somewhere, it received it from an exothermic reaction. If your water gets colder, it lost heat somewhere, it was absorbed from it from an endothermic reaction. So just remember that. So here's the first problem. It says when 5 grams of liquid toluene, and I give you the formula liquid toluene, C7H8, is burned, it causes 500 milliliters of water at 20 degrees Celsius to rise to 40.3 degrees Celsius. To rise, the water gets warmer, therefore we're dealing with an exothermic reaction. Which makes sense because it says what is the heat of combustion for liquid toluene in kilojoules per mole. Now my problem is a couple things. I need to get my Q, which is my energy, but when I do it with my specific heat always gives me my energy in joule. I will need to change that to kilojoule according to my answer. My other problem is my amount, my liquid toluene, is in grams, so I have to get from mass to moles. That's why I gave you the formula, so you get the molar mass, you get that from the periodic table. So first of all, my Q. The Q comes directly from the water. I have the mass of water for 500 mils. I know my specific heat, 4.184 joule per gram degree Celsius. And then I have my delta T, 40.3 minus 20.0. Again, keep your eye on this point because if sig figs change, it will change right here. As of right now, I'm looking 3 sig figs with my 5 grams, 4 with 500 milliliters, and 3 with both my temperatures. So I'm looking at 3 sig figs. Well, my delta T maintains those 3 sig figs. So I get my Q. Now what I'm going to do with my Q is I'm just going to change it over to kilojoules. So remember, from joule to kilojoule, we move it 3 places to the left. And then we keep 3 sig figs. So my 42.4 rounds up to a 42.5 kilojoule. That's my Q. Now I'm going after my amount. Well, my amount, my problem is in grams, and I want it in moles. So I look at my liquid toluene, I add up 7 carbons and 8 hydrogens, and it weighs in at 92.15 grams for every 1 mole. And I put moles for grams, not grams over moles, for one reason only, so my grams can actually cancel out. So I said the math I'm doing is simple division. So I have my Q and I have my amount. Now I just finish out by simply dividing. And my answer will have 3 sig figs. Now I have to put a negative sign in front of it. Why? Because it's exothermic. Mathematically, it does not come out. I have to put it there. And it's now kilojoule per every mole of liquid toluene. The next problem reads, what is the delta H of a reaction that lowers the temperature of water? Now my water is getting colder, so something absorbed. It's an endothermic reaction. So now I'm going to put a positive in front of my answer at the very end. So I have my water. Remember, that's where I get my Q from. I have 1 liter of water, and it was my delta T is 4.18. My delta T there is 7.5. When 5 grams of a substance, and I give you its molar mass, is reacted, give the answer in kilojoule per mole and then calorie per gram. So in this situation, I look at it and I have 1 liter of water, which is the same as 1,000 milliliters. And so I have 1,000 milliliters times 4.184 joule per gram degree Celsius, that's my specific heat, times my delta T, 7.5. And I end up with, again, in joule, I end up with 31,380. But I want kilojoules, so I'm going to move it 3 places over to the left, and it'll be I'll keep the 31.3, and my 3 gets rounded up to a 4, so I have 34.4 kilojoules. That's my Q. Now I need to work on my amount. My problem is my amount is in 5 grams of the substance, but I want to know moles. So I have molar mass, I gave it to you, and it's 120 grams per mole. I put moles over grams, not grams over moles, for one reason only, and that's my grams are actually opposite and they actually cancel out. So again, I'm doing simple division. So I'm going to take my Q and divide it by my amount, which is 0.0417 moles, and I find out my, again, my delta H. Now I have to put a positive sign in front of it. I can't leave it as understood, even though it comes out as a positive value. I must physically put a positive sign in front of it, and that's the delta H for this reaction in kilojoule per mole. Now, if I want to change it to calorie per gram, I could just actually make it really, really easy and go up and for my Q and change my specific heat from 4.184, just change it to 1 calorie. Therefore, I'm just dealing with 1,000 times 7.5 divided by my amount's already in grams, so I then divide by 5, and I'd be done as well. Or in the process, you can go through some more dimensional analysis, and here's my answer, the 752.52 kilojoule per mole, and I'll change my kilojoule to a joule, and then go from joule to calorie, excuse me, and then I'll go from moles out to mass by using molar mass, and which is 120 grams, and my moles cancel out and end up in grams. So I end up with calories per gram. Now in this situation, again, I can only have 3 sig figs. So my 1,498, we round up to 1,500, which is only 2 sig figs, so you have to put it in scientific notation. And there's a positive sign. Once again, let's go into that because it is an endothermic reaction.